Okay, so we are now recording. I'd like to welcome everybody to the NAL First Thursday program. Today is December 5th, and it does appear that winter has finally arrived in Houston, at least for a couple of days. But as a result, many of us are going to end up heading to warmer climates for the holidays. I'm Lisa Spence. I'm going to be your host for today. And our speaker today is Mr. Paul Boehm. So a little bit about Paul. Paul is currently the functional area manager for the Orion spacecraft crew life support, thermal spacesuits, and flight crew equipment hardware. He's going to provide us with some insights in the history and philosophy of the design and development of the Orion crew systems and the ECLSS system, which ultimately will support the astronauts on the Artemis missions. So Paul began his career in 1989 at the Johnson Space Center with Rockwell Space Operations and then United Space Alliance. He joined NASA in 2006. During his career at JSC, he has worked as a support engineer for the astronaut office for 5 years, spent 14 years as an EVA flight controller and crew trainer supporting shuttle and ISS operations, and 3 years in the EVA project office for the Constellation program, working new lunar suit development. In 2011, he began serving in the Orion program crew and service module office as the deputy functional area manager before taking over as the FAM. So Paul is originally from Elmhurst, Illinois, near Chicago, and he attended the University of Illinois, where he received both his bachelor's and master's degrees in aerospace engineering. So that's a little bit about Paul. He actually is also the father of 2 adult ladies, young ladies. He's pretty much gotten him off the payroll, so he's quite happy about that. And
Almost.
he is one of the best in the neighborhood at decorating his yard for all of the holidays. So I'm going to go ahead and turn it over to Paul, who has been kicked off of Zoom again, but he'll just keep logging back in. All right, so I'm going to go ahead and turn it over to you, Paul.
There we go. I'm not sure what was going on there, Lisa, but finally got unmuted, hopefully. All right. I apologize for the connection, and hopefully it will go long enough that I can get through this. You guys should be seeing my screen. As Lisa mentioned, I'm going to talk to you a little bit about the Artemis 2 mission, specifically the crew activities that we've been working on over the years, give you a little bit of background about the vehicle. And then, because I'm not quite sure how much folks have heard on details, but then also I will give you a little bit of background on some of the challenges we faced over the years with the Orion spacecraft. So you go to the next one here. So Lisa kind of mentioned all the stuff about me already, so I wasn't going to spend a lot of time. This is kind of my standard intro slide for folks who don't know me. But yeah, I'm currently in the Orion program office and the crew and service module office. As Lisa mentioned, I'm the functional area manager doing the ECLSS system, the active thermal system, passive thermal system, flight crew equipment, and suits. And so pretty much everything related to the crew stuff inside the vehicle and even outside the vehicle on the thermal systems I'm working with from a hardware management perspective from the program side of it. A lot of the system managers report to me from the ECLSS, from the active thermal, passive thermal suits, all that type of activity. So I worry about all the programmatic budget and schedules for Orion for these particular areas for the hardware development, and work closely with our Lockheed prime contractor on the development of all those particular items. And I, like Lisa mentioned, I've been here in 1989, started off up in the astronaut office, and I love working on the crew systems hardware. I've been doing it for many years through that, and then also through EVA, and many years spent there, and then coming over to the program side and working within the program offices, originally over in Constellation when that was still alive, and then into the Orion program when I came over to do that, and starting in 2011. So I've been in the crew and service module office since 2011, working all this hardware. So it's been quite a change over the years of what's happened with Orion over that time span, and we're really getting to what I've been waiting for a very long time, is the exciting part now, and challenging part of having the first crew fly on Orion. And so I was going to talk to you a little bit about that, and give you some more background. So real quick, the build up to the first crew flight. Hopefully most of you know that we did a ascent test back in 2010. We did the first flight of Orion capsule on EFT-1 back in 2014, launched on a Delta Heavy. We did a ascent test, abort test back in 2019. And then we did the official Artemis 1 launch in 2022 on SLS for the first flight of the SLS and Orion together. And now we're getting towards the next big step, which is go ahead and put crew on Orion and do the Artemis 2 mission here. And if you did hear the news today, they just announced, I got to update my chart, that the no earlier than April of 2026 is the new launch date for Orion for Artemis 2. We're shooting for a September 2025 date. We've got some testing and things like that we're trying to prove a few things out. And then we had to make a decision about the heat shield. And so that was actually just made today. So that's why the new launch date was announced. So that's a good thing from the perspective of we know what we're shooting. All right, hopefully I'm back with you, and I apologize. So I can hopefully tell when I'm dropping out, and you guys tell me if I'm good getting back in. All right, let's see. So next one. So this is one of my favorite pictures. I was standing in the mirror when we were flying Artemis 1, and just to be able to sit there having worked some shuttle missions and ISS build and everything, it was just a really awesome feeling and an incredible experience, sitting there staring at the TV monitors and looking at the moon back towards the Earth, and knowing that hadn't been done since the Apollo days, which have always thrilled me to understand what was done during Apollo, because it's amazing to me, the work that was done back then. And so this is one of the picturesque shots from Artemis 1, when we were at that point where we were the farthest away from the moon, and had the great shots looking back at the Earth and the moon together. And so this is basically what I'm looking forward to doing with the Artemis 2 mission here. So Artemis 2 itself is going to be essentially All right, I apologize that keeps dropping out. Sorry about that. It's going to be like the Apollo 8 mission, where we're essentially doing the free trajectory fly around the moon. And so right now, that's the one that we'll be shooting for the April of 2026. And as part of this mission, We're going to be trying to demonstrate a little bit of the rendezvous and proximity operations. We'll be doing that right after we get into the Earth orbit, and we will be essentially doing a rendezvous and docking test with, not necessarily docking, but rendezvous prox ops with the upper stage once we do the TLI, or before we do the TLI, actually, because we're actually going to be using the Orion to boost us as well for going to the moon. So that is the two big items that we're testing on this: is the crew with the ECLSS system. We're doing a high Earth orbit initially for 24 hours, and then we'll do our TLI to send us to the moon. And that gives us a time period to be able to kind of check out the ECLSS system and things like that, and get a little stable before we go ahead and do that TLI to go to the moon. So it is a
Paul, you need to unmute.
Yep, thank you. Just yell at me. So it is kind of a challenging mission for the first flight. So, but that was what the program had set up many, many years ago to try to aim for. All right, so then our next one is just the Artemis 2 crew. Again, Reed Wiseman, Victor Glover, Christine Koch, and Jeremy Hansen are 4 crew members that were named earlier this year for Artemis 2. And so really looking forward to having them fly in our spacecraft and be the first ones to go around the moon in a very long time.
Hey,
Paul, you
Paul.
need to reshare your screens.
Yeah, we lost your share.
About that. Thought I had that back on. Thank you. So the 4 crew members, and really looking forward to having them fly on the Artemis 2 spacecraft. And it's been a long time coming for that, for being able to get back around the moon. I know I'm excited about it because this is the closest we've ever been to being able to go do this, and the entire time I've been here at JSC. All right, so tell you a little bit about where we're at with the spacecraft. So for Artemis 2, we just are lifting today out of the vacuum chamber down at KSC. We were doing some more thermal vacuum testing, vacuum testing on the vehicle, and where this is essentially the final. So this is the final integrated testing phase that we're in. And so after this, it was really just basically putting the final touches on the vehicle, closing out the inside of the vehicle, and then getting it ready to transfer over to the ground system folks to start doing the processing to install the launch abort system and do some propellant loading and the consumables loading over in the MPPF. And then it heads over to the VAB for the stacking onto the rocket. But that's what the vehicle currently looks like. And as I said, they were just pulling it out of the vacuum chamber today to be able to continue processing on it. A couple more pictures of what it looks like. This is actually the picture on the upper left is when they were lifting it into the vacuum chamber down at KSC. For those of you familiar with the O&C building, that's the high bay of the O&C building that was turned over to Lockheed to do all the Orion processing in. And so that's currently where we're building up the vehicles. And right now, the Artemis 2 vehicle, the Artemis 3 pressure vessel and vehicle and parts are starting to come in. And then the Artemis 4 pressure vessel is getting there. So we're going to have three of the vehicles down there very shortly. And let's see. So if you're not familiar with Orion, it does have the launch abort system on the top part, which will basically carry you away from the rocket at about 0 to 400 miles an hour in like 3 seconds. It's pretty amazing. And then the crew module, which is where most of our ECLSS system is at. The service module is obviously propulsion and power, and then also the consumables, oxygen and nitrogen that we're using for the Orion spacecraft, and water as well for the crew is also in the service module. And then obviously with Orion, it's solar arrays for power generation. For the ECLSS system, we've got 7 major functions, and I hit a couple of them that I just talked about. But the first one is the air revitalization system in the crew module. We have suit and cabin loops, and fans provide the cabin air circulation, the suit loop circulation. For the suit loop, we only introduce the pure oxygen into that loop, but we're doing oxygen and nitrogen for the cabin control. So we do have the CO2 and humidity control, removing trace contaminants, doing air monitoring and post-landing ventilation. Pressure control is for both the cabin and the suit loops. We're providing the cabin pressure equalization, positive and negative pressure reliefs, and oxygen introduction into the suit loop, and oxygen into the cabin, and then nitrogen into the cabin to do that. And the crew module has its own standalone oxygen tank for reentry purposes. Active thermal system, we have parts of it in the crew module. We also have parts of it out in the service module. That's what's rejecting the heat. All the avionics are on cold plates in the vehicle. And then also we have heat exchangers for the air that essentially will remove that heat load and transfers it to the service module to be dissipated through the radiators on the service module. The service module has got those pressurized tanks for water, nitrogen, and oxygen consumables, and the heat rejection via the radiators that I just mentioned. Portable water system, we have a dispense capability within the crew module. It's very simple. It's essentially 2 plug-in ports for water dispenser with a manual valve that the crew turns. And then the pressurized water tanks are actually in the service module for delivering the water for the crew. We do have our universal waste management system, which is a toilet for the solid and urine waste collection for the crew. And we do plan on venting that overboard during the mission. And that's essentially how we get rid of those commodities. And then fire detection and suppression, essentially your smoke detectors, portable fire extinguisher, breathing mask. And for Orion, we've developed a system to where in case you do have a fire, we have a filter system that the crew installs to basically remove the cabin smoke contaminants and get it back to an atmosphere that it would at least allow the crew to get into their suits so we could depress the cabin and essentially vent overboard all those nasties from the smoke situation. So we had to develop that type of system for Orion. Since we don't have anywhere to go, we got to be able to deal with it. Real quick on the crew module cabin configuration on the inside, essentially we've got our upper part of the vehicle, which is the habitable area that the crew is in, and you have the 4 seats for the crew members, and then down below the deck, if you want to call it that, is our locker stowage areas, and all the avionics are there. Along the one end of the vehicle is the ECLSS life support systems in the ECLSS bay. And then we have a bay underneath the floor where the toilet is at. And then a lot of the active thermal system with its plumbing system is also down below the floor. So it's the way I always describe it is it's you and your three favorite friends in a VW bus for 2 weeks at least. So, but that's the configuration of the Orion capsule for what we're doing, trying to meet our 4 crew for 21-day mission. All right, a little bit more in detail about the hardware and what we were doing with Orion for life support. Looked at. Let's see. Hopefully, you guys are still hearing me. Hey, Lisa, can you hear me?
Yeah, we can still hear you, and we're still seeing your screen. Thank you.
Great. Yeah, just getting weird notices on my Zoom. So for Orion, many years ago, back in probably the 2008 timeframe when things were starting to put together, the look at it was, hey, we need to take some lessons learned from previous spacecraft, see what we can do to kind of simplify things, to try to remove as much complexity out of the hardware so that you can try to avoid failures. And so things like the CO2 removal system, we do have this amine CO2 removal material that essentially all you do is expose it to vacuum, eliminates the ejects the CO2 from the system. Of course, that does take some consumables when that happens, so we have to balance that. But essentially, it's almost like a lyo canister with a motorized valve on top of it, and so that's our CO2 removal system. It also removes humidity as well, so we don't have separate water humidity separators in the vehicle. And so we control that CO2 and humidity through this one unit from that perspective of venting it overboard. We don't have condensing heat exchangers. We manage the dew points in the cabin and temperatures so that we don't have condensing on the heat exchangers. And so that was something else that we were trying to avoid, is having additional hardware like that we possibly have problems with over time. Waste management, this is one that we had to really reduce the mass and the volume of it in order to have something that was comparable to shuttle and station and previous vehicles. So we came up with a new toilet system that's based on a bit of the shuttle EDO extended duration heritage, but it is a single fan motor unit and very simple, straightforward to use. But it really reduced the mass and volume. I think it was by like 50% on what the shuttle system was. And then consumable storage. One of the big things was I know I wasn't here at the time, but before I came in, there was a lot of debate about cryogenic tanks and things like that. And so the decision was to go with high pressure gas tanks for oxygen, nitrogen. So we don't have the cryogenics doing that. And we just have pressurized water tanks for water storage. And then we basically fill those before flight and then have those for the portable water system for the crew. And so that's kind of the philosophy that was used with Orion to build up the crew systems portion of it, to try to help take some lessons learned from previous hardware and try to make the items for Orion simpler. Now, I will tell you, it doesn't mean they're necessarily simpler with some of the issues we've been working with through development, but the theory is that we're trying to minimize the types of hardware to where we can have additional issues going on. So this one, just to give you a quick overview of the ECLSS system in Orion. So this is, I mentioned the 2 loops in the vehicle. The cabin loop, I don't know if you're seeing my pointer here, but is the darker green lines in the center of the picture there. That is the loop that essentially just circulates the air within the cabin. And provides the vast majority of cooling of the air, circulation of the air for CO2 control in the cabin. And so that's the cabin loop, as they call it. The suit loop is the yellowish loop And that's the loop that we can essentially isolate from the cabin and put the crew on it with the suits. And that one also is the one that has the CO2 humidity removal, trace contaminant, and heat exchanger in it as well for the crew when they're in the suits. So that's what the suit loop is. And so we use both these loops together to do the air revitalization system of Orion. And then feeding into those two loops are your oxygen system in green there, which is from the crew module and service module tanks, pressurizing either the suit loop with oxygen or the cabin with oxygen. And then we also have nitrogen tanks out in the service module that pressurize with the cabin with the nitrogen to make up for cabin pressure over time. And let me go to the next one here. This is a high level one picture of the active thermal system of Orion. And with this one, essentially you've got three major areas that we're working with. Starting on the far right with that one, that's the European service module. That's where the radiators are that do the heat rejection into space. There's the HFE loops, flowing HFE fluid through those loops to do that cooling heat rejection. They flow through a pump system. That pump system pumps it to an interface heat exchanger, which is there in the center box, and that's in our crew module adapter, which is right below the crew module. And that's where the interface happens between the service module's cooling system and the crew module cooling system, which is based off of PGW water loop. And so that exchange happens there for transferring that heat between the crew module and the service module. And then in the crew module, we do have cold plates on all the avionics within the Orion spacecraft. And we did have two main heat exchangers for the cabin air, which is the cabin heat exchanger that I talked about earlier, and the ARS heat exchanger, which is on the suit loop. We also have the LWC, which is the liquid water cooling loop, which is the LCG loop for the crew when they're in the suits. And so that's also cooled by the PGW loop as well. For Orion, we have an ammonia boiler, which is what we use for ascent and then also re-entry for cooling. Once the service module radiators become inactive, we essentially use the ammonia boiler to cool that PGW loop in the crew module. And so that is a consumable that we use. But the vast majority of our cooling is coming from the radiators on the service module. And for Orion, we actually have a new one, which is the phase change module. That's the PCM that's in the middle there. That is actually a block of wax. So we melt that wax when we need to dissipate additional heat, and then it chills down and freezes. And again, when we basically need to cool things down or warm things up. And so that gives us a little extra to work with from a heat rejection storage and rejection capability standpoint with our PGW loop in the cabin to help also minimize that fluctuations to that loop. And so that's kind of an overview of that. And then just kind of give you how we're testing some of this hardware from the perspective right now. The Integrated Test Laboratory, that's up in Denver. That's actually very similar to the Shuttle Sail Laboratory here at JSC. It's a full up avionics, all the flight hardware, sensors, flight software. It's identical to the Orion spacecraft. And so we're doing for the ECLSS system is we are using that to test the algorithms, the software algorithms that are controlling the cabin pressure control, the cooling systems. And so we are able to use the flight software, and we connect to our digital motor controllers and the sensors for those in the lab. And I'll talk a little bit more about that in the next one. But the digital motor controllers are kind of our key brains for the ECLSS components in Orion. They actually can control the ECLSS hardware if the entire software system of the vehicle goes down. We did that from a standpoint of redundancy and safety. If the vehicle has a software issue to where the flight software is computers all go down, that we can actually still have basic CO2 system running, some very basic, there's actual manual pressure control introduction to the cabin, things like that. So even if the entire flight software goes down, the crew has time to be able to react to that and get the system back up and running without having to worry about the fact of losing your ecosystem right away. So that's with the digital motor controllers that we have, which are a lower level electronics box attached to certain pieces of hardware. They provide self-contained control of the ECLSS components. Then the next one is our integrated life support facility we have at JSC. This is actually in Building 7. It's the old 11-foot chamber that was used for Apollo and shuttle and station for EMU certifications. And so we actually built this one up to be the Orion ECLSS test bed. And so we have taken components from the qualification components and that from the ECLSS system, installed them into a portion of the chamber, and then we're able to put four test subjects in there and hook them up to the Orion ECLSS system and test that. And I was lucky enough to be able to do this twice back in 2015, 2017. It was a neat experience. But this is really just testing the integration of the system because we do a lot of the qualification testing on the components themselves, but we're also just trying to see how the integrated system reacts to each other when you start hooking up pumps and motors and regulators and introducing oxygen into different portions of the system and things like that, just making sure we're seeing how all that interacts. It's also the first time that we've ever hooked up the actual vehicle flight software into a NASA human rated test chamber. We actually created two racks that hold it basically runs the simulation of the vehicle flight software is loaded on those racks, and then that is actually interacting with the ECLSS hardware here in the chamber, just like the vehicle would. And so we actually have that capability to kind of look at how the flight software interacts with the hardware, because that was something we wanted to make sure we're catching as well, because the only other place to do that right now is on the vehicle at KSC. And so because the ITL that I showed you earlier, unfortunately, does not have all the ECLSS hardware installed in it. And so the only place we have that is here at JSC. And we're using this facility to test things like a cabin leak scenario, where we have to get the crew in the suits quickly to be able to go to a depressurized cabin state and get them home in the suits. And we also go through the suit pressurization depress operations, the suit leak checks and things like that. We're testing all those things here in the OLIF as well. And then we do plan to have a test on the vehicle coming up here, probably early 2025 here, where we'll be putting the crew in the vehicle as well and running through similar operations in this for the ECLSS system also. All right. Talking about ECLSS, but I also got to talk about some of the other flight crew equipment that we have. The suits were a brand new version of what we upgraded the shuttle ACES suit essentially to become the Orion suit. It was modified for the closed loop operations that we need for Orion. Also had several occupant protection upgrades that were lessons learned from Columbia. And so one of the really kind of interesting ones on it was the fact that between the seat and suit interface, making that very more conformal to fit the crew, but also even things like the helmet holding on the suit, that it actually has a device that maintains the helmet posture on the suit with the helmet in relation to the crew member's head, so that the helmet and neck ring are not flying over, past the crew member's head and basically creating head damage. So that was a lesson learned from Columbia. And so we've basically created the suit to also do the unpressurized cabin return capability. Orion has a requirement for up to a 6-day return with a depressurized cabin. I will say that is probably the most challenging portion of creating an ECLSS and suit system to try to meet that type of requirement. Has a lot of risk associated with it. I think essentially where we've gotten to, and I did a lot of look back at Apollo and the 115-hour requirement that they had in their suits and things like that. And I think where we've gotten to is that we think we can get the crew home alive. We just don't know how great a shape they're going to be in when they get home. And so that's kind of one of the risks the program's accepted with that type of duration. Putting somebody in a suit for 6 days is not a fun thing. But we also improved the sizing of this from the shuttle suits. It's a lot more personnel size than they were on shuttles. Shuttle suits tended to be more a generic sizing, a little bit looser fitting for crew members. So we've kind of made a lot of changes to this particular suit to be specific for Orion. There's also new flight crew equipment we've developed for Orion, new radiation sensors, medical kits. We came up with a rowing device that's a flywheel exercise device for Orion because we needed something that was lightweight to be able to support a longer duration mission. And so that device was built up for Orion. And food and things like that, we tend to borrow from the ISS experience. Not too many changes there. We did have to make changes for trash bags and cargo nets and water bags and things like that we had to do for specific requirements. One of the other new ones is this 6-day return requirement in the suit. We developed a feeding mechanism, essentially, that will do not only food capability, but also hydration with water. Our suited nutrition and hydration contingency bags. You see a picture there on the right-hand side on top. Basically, that goes in through a port on the side of the helmet. It actually uses the suit pressure to pressurize a bag around a bag, which makes it very easy for the crew to be able to get the materials drawn in through the straw through the suit helmet. So we also came up with a new collapsible contingency urinal bag that is both for males and females. So that was something that we had to develop to be able to make sure that we had a capability in case the toilet fails. Do we get the urine out of the vehicle? And essentially we developed these collapsible contingency urinals that actually we tried them on ISS already. They worked really well. A unique thing about it, which the picture unfortunately doesn't show you, it has these veins in it which actually wick the urine down to the bottom of the bag in microgravity. It works really great. And so then we vent the bags overboard. So these are some of the things that we've had to develop for Orion because of its specific purposes and doing longer duration missions and trying to fit into the scheme of Artemis as a whole. Some things that we've been looking at. All right, so some of the development challenges that we've had over the years. The biggest one that I've seen from my perspective, being here since 2011, is the deferment that we had after Constellation went away. We were at a vehicle level PDR back in 2009, and essentially the crew systems were kind of put on pause at that point. And that was due to the budget constraints during those years with the agency and the program. And so from 2011 to 2017, really, there was very minimal actual real development work going on for the ECLSS and crew systems because of the cost issues with the program. And so we did get in some chamber testing with development hardware that we did do with especially the CO2 removal system, what I call the XPIS chamber, several different series of chamber runs that we did that you saw with those 4 folks in the chamber, that we were testing out as much of the integrated system as we could with some of the development hardware that we had from the time. We also went through ECLSS scrubbing of the system due to the mass and cost back then during that time frame, even before we had gotten a chance to be able to really get to a PDR level at the components. Mass was being taken out of the system at that point. So that put challenges on, how heavy things could be. Probably something everybody knows of, going back to the moon. Mass and volume are premium. And so then we picked up with component level PDRs of some of that hardware that we're talking about for CO2 removal and active thermal system back in the 2017, 2018 timeframe. We got into CDRs in 2018 to 2019. And then most of the hardware for Artemis 2 was actually delivered in the 2021 timeframe. So we're talking about 4 years there where we started with the PDRs and we're delivering the flight hardware. And so I know that sounds sometimes like a long time, and maybe it isn't. But from a perspective of starting kind of again and picking things up with the team and getting going, that was kind of a challenge because we had a lot of turnover during that time frame as well. And with personnel. And so it was a challenge being able to keep things consistent over all those years. And so that's something that we faced as well during that time frame as a challenge. Probably the biggest difference, I think, with the Orion program has taken is building the flight hardware before the qualification hardware. That is not the norm. That was a risk that the Orion program, even when I came on, it was already kind of starting to move that way and set in stone. So the risk was acceptance of late hardware issues discovery versus trying to accelerate the schedule of the vehicle build. So the flight components were actually built, acceptance tested, and shipped before the qualification units were completed and tested. And so that was the challenge. To me, that's probably been the biggest challenge for Orion, different than probably most other programs ever have done. So the whole vehicle has basically been built this way from that perspective. And so with that, you do run into the problem that you're building the first build hardware goes into the vehicle, and then you run the risk that you got to go rework the flight vehicle because you find something later. Most of our components from a qualification standpoint actually were able to get through without impact to the vehicle. But the problem is it only takes one of 70 components to create a problem, right? And so we did have a few of them that we found the issues later during qualification, and we required hardware removal from the vehicle to go modify that hardware and then reinstall it in the vehicle. And even some issues we were found not only, were found even after the qualification of the Artemis 2 hardware. It was found on the next build of the production hardware for Artemis 3. And I say production, second build of the hardware, really. And so, that also poses a challenge with this particular one. It isn't even just finding it during the qualification. Is when you have an issue that you find later, you got to go back and look at your previous builds and say, does that apply? And we had one of those happen with a piece of Artemis 3 hardware that we built. And that happened last year with our digital motor controllers, where we found an issue with those. And we had to actually do some workaround on the vehicle to be able to put Artemis 2 back together again. Hardware challenges, I think, are things that are probably pretty familiar to folks. But with ours, it was that compressed timeline with the ECLSS system, with that deferment. It meant a lot of the other systems on the vehicle have actually got to fly almost twice already on EFT-1 and Artemis 1. We pretty much had to take the ECLSS system, put it together, design it, do all that effort, get it on the vehicle, and we're going to our first flight. So that has been a very big challenge for the hardware itself to make sure that we're getting that right the first time, because that's what we need. The environmental loads have been a big challenge for Orion. Vibe and shock been pretty interesting. When we started out, we were literally breaking vibe tables with the loads that we were having to go to for Orion because of the landing loads with the size of the vehicle and the loads from SLS launch and things like that. So that's been a big challenge for us is having to you know, be able to test that type of capability. And so I think we've gotten over that hump. People have beefed up their vibe tables and we found new shock tables and things like that. So that's been worked over the years. Other big challenge for us has been just electronic parts, which are standard now. I mentioned the digital motor controllers. Unfortunately, those take about 1.5 years to go build those things. And so it's not something that you just turn on right away and say, I'm going to have it in 6 months. And so the electronic parts, especially like during COVID and things, and we're still experiencing some of that to where, the first thing we ask is, when are the electronic parts coming? Because that tends to be your longest lead item. I mean, we've got AAA parts that some of them are 52-week lead times right now. So that is a challenge for us as well. Mass is another big one. We essentially have, I think just like Apollo, every pound has been scrutinized on this vehicle, even down to the half pound. And so even that, we're looking at everything we're adding to the vehicle. It's been a challenge. I've been through 6 official vehicle mass scrubs just within 7 years during that 2010s timeframe. And that was, as I mentioned, was even before we had hardware started with PDRs and things like that. We were already taking mass off of those pieces of hardware on paper. And so unfortunately, that tended to be, of course, counterintuitive or counter to the environmental loads, to where you do need a little bit more mass and structure on components to handle the loads so that you don't end up with fracture and fatigue issues and things like that in the structures of them. So that's been a very big challenge of balancing that for Orion. And then stowage, probably the last one. Volume constraints it's a premium on the vehicle. You need to be thinking about what's mandatory. What do you really need to fly? This isn't shuttle and it's not ISS. I know it was a paradigm shift for me coming over to this, that this is a camping trip, and you need to be taking what only you need to take with you. So that's been a big shift to get back to that Apollo paradigm of, you need to be really scrutinizing what you're taking with you, because we just do not have the mass and the volume to deal with that when we go into the moon. And I did throw this one in there just because back in 2015, I think it was, we were doing a review. Jerry Goodman, who worked the Apollo Crew Systems area, he actually made this cartoon back in 1965. And I have it hanging on the wall in my office because it's still applicable today. It's exactly what we're going through on Orion, from the standpoint of, everybody has their piece of hardware that they want to put on. I even have my own piece of hardware I want to put on. And crew comes in, hardware owners are coming in, program managers are telling us what we need to fly, and it just is a constant battle. I feel sorry for our mass control panel guys. They are just going crazy all the time with trying to beat down everybody on adding mass to the vehicle. So, 60 years later, it's still applicable, just because obviously physics don't change really too much. That was kind of a brief overview of the crew systems and ECLSS for Orion, and I wanted to open it up to any questions folks may have. And I know Lisa said hold questions, so this is the time you get to ask, and hopefully I can answer them for you.
Paul, thank you so much for that. That was really a lot of detail. I was trying to take notes and I got way far behind. We did have one question that came in the chat, and it had to do with the wax. So how much heat can the wax actually remove?
Oh, I'm sorry. I knew somebody might ask that question. I do know it's 42 pounds of wax that we're flying.
Okay,
I was I honestly cannot remember off the top of my head
no
the amount
problem.
of BTUs that it can handle. The PCMs themselves are actually they were actually really added for the when Orion was initially designed back in the early 2000s. We were set to do the low lunar orbit missions, and the PCMs were actually added to help with that capability. So, like for Artemis 2, we actually don't even plan to use the PCMs just because the rest of the system can handle it when we're at high enough altitudes from the lunar orbit. And so the PCM we actually don't even plan to use for Artemis 2. It's only used actually during ascent to help offset. We do freeze it right before ascent, and then it's used during ascent, and then during these ammonia boilers take over and begin to actually do the real heat rejection once we get high enough for the altitude for the ammonia boilers to kick in. And so that's how we kind of use the PCM, but it's actually really not I want to say a significant part of the active thermal system that we rely on. It's more of a supplement to the active system.
Okay, great. All right. So Dave, if you want to go ahead and unmute so people can ask
Yeah.
questions, or you can still type your questions into the chat and we'll get to those.
Yeah, I have it so that everybody can unmute if they so
Okay.
choose. Be perhaps good to do a hand raise or something. That way, keep it
Yeah, that would be
ordered.
good. All right. We're open for questions. All right.
Well, if no one else has a question, I've got one. So, since it seems like the ECLSS system has not been flown prior to the first manned crew mission, is there a checkout time in Leo before a TLI burn to check out the ECLSS and a contingency to return if there's any major problems with it? And how long might that
Yeah,
time be?
yeah, great question. It has been one of my biggest concerns, obviously, and I think a lot of folks is how do we make sure we have a good ecosystem before we do that TLI burn? So with the Artemis 2 mission, right now the plan is we will launch and then we do an apogee rage burn and we actually go into a high Earth orbit, a HEO orbit, which will be a 24-hour orbit around the Earth. And so we do that to basically have that 24-hour period to where we're checking out the ecosystem and running it, getting it to a relatively stable, steady state. We do some things where we go through and we're actually going to try and do an exercise period right before we do TLI just to kind of stress the system a little bit. And so that's our period of doing the checkout. Years ago, even there was talk of trying to do it, within 90 minutes of doing and trying to do the TLI after 90 minutes, one rev around the Earth. And so I'm kind of glad we went away from that because I personally did not feel that comfortable with that. And so I'm good with the 24-hour period. And we've done things where we've also added 2 cans of shuttle IO to be able to have some dissimilar capability for like the CO2 system for that checkout period. And so we're trying to be cautious about it and make sure we're doing the right thing. But that's where we're doing the checkout of all our ECLSS systems is within that first 24 hours before we do the TLI.
Okay, and a entry is possible after that checkout if we
Yep.
needed to.
Yep, exactly. Yeah, and that's why the good thing is we're no more than that 24 hours or so home.
Yeah, I think even as of 2013, when I retired, I think they were still not going to have the ECLSS checked out prior to putting crew on. So I think that's been a standing issue for a long time.
Yeah, it's been a challenge. I know since I've been here, we have talked. I mean, we've talked twice putting ECLSS system back on the Artemis 1 vehicle. We talked about putting on the EFT-1 originally, but it really unfortunately it just tended to boil down to budget constraints. And that's why the system was kind of deferred. It's not a cheap system, I'll be honest. There's a lot of components to the ECLSS system, and I think people tend to think of the ECLSS. We all get, we all breathe and and know how we do ECLSS, but the challenge with it is you get not only the electronics, you got the fluids, you got the pressures, you got the size of complexity of components being put together, and so it tends to be a pretty significant effort, and there's about 40 different components to ECLSS, and each one of those tends to be a CEI that's like that, to where it has a lot of those components to it. So it's not necessarily a simple, straightforward system, and does tend to cost a bit more, unfortunately.
Did Orion overall ever get away from their distributed proto-qual approach that Lockheed Martin was
No.
pushing?
Yeah, so we still do that. And that was actually the vacuum test that you saw was actually a result of years of scrubbing through the test and verification plan of Orion, and seeing where you could say, can I do this type of test here and do this test here, and spread things out, versus building a complete qual vehicle and doing that qual through that. So that vacuum test pictures that I showed you is one of those results of doing a vacuum test with the Artemis 2 vehicle before you fly it. Because the thermal vacuum test of the vehicle was actually done on the Artemis 1 vehicle up at Plumbrook before we flew it. And that's the only thermal vacuum test of the vehicle that we're actually planning on doing in the program.
Yeah, and last
We do a thermal cycle, and then we do a vacuum test, but we don't do a thermal vacuum test anymore.
Yeah, maybe a last one for me here, but are you doing any kind of a gross pressure leak test like we finally ended up doing on Node 1 after the KSC vacuum test at ONC, and then we had been opening the vehicle and doing stuff and closing it up, and ended up finding that there was an equalization valve that one side was left open that we detected only with the gross leak test.
Yeah, for Orion, we are doing the vacuum tests, but when let's see, I'm trying to think through when we get to the VAB and get stacked on the rocket. A lot of I think the good thing is we have indicators that you can look at inside the vehicle to determine certain positions. We also have, honestly, pretty few pass-throughs of valves like that. That for Orion, which is kind of nice from that perspective. We do have obviously all the electrical and tubing pass-throughs that are buried in the vehicle, but from a valve position and things like that, it's pretty few that actually do pass-throughs.
Yeah. If you're not familiar with it, you ought to go research that history about the gross leak test on Node 1.
When was that done? Right before it launched?
A little bit before launch, yeah. It was after qualification. The argument had been it had been through qualification. It was all good enough. We'll open up and close hatches and do this, and we don't need to do that test. And we had one of our Russian engineers that had experienced the Salyut 1 crew loss because of loss of pressure, who was working for us and insisted that we ought to do that test. And as integrated T&V, we pushed for it, and we found a major place for air loss.
Was it just a pressurization test
Yeah,
of the node?
yeah. We basically put it in the canister to ship it out to the shuttle, and we pressurized it a little bit. We depressurized the canister and had a high concentration of helium and helium detectors.
Okay, good to know. I'll
Yeah,
look at that.
it surprised everyone because the checklist had air equalization valve on the hatches, checked, closed, signed off, closed. Didn't realize there were two ways to open that valve, or two valves, one inside, one outside. Probably won't apply
Ah,
for
gotcha.
Orion, but still, it was one of those things, trying to save time and schedule and cost.
Yep.
And
Yeah,
Can we get
I
another question in?
totally feel for you.
yep.
Another question?
Go for
Uh,
it.
Yeah.
yeah, Paul, this is Stokes McMillan. Would the systems and the soups support a EVA?
They actually can handle going to vacuum, and we can move around in these suits. That was another part of what we did with the modification of the upgrade to the old shuttle suits. Was we actually repatterned shoulders and things like that to have a little more mobility in these suits when you're pressurized. They Orion does not have the capability to do true EVA, like go outside the vehicle. We do have the capability to have the crew be in the suits at 4.3 psi pressure in an evacuated cabin for those 6 days. So we do have the capability to go to vacuum in suits, but we do not have the capability to go out EVA. That was actually removed, or I want to say probably in the 2013, 2014 timeframe from the program, again, for budget and mass considerations. And unfortunately with Orion, a lot of it is just the fact that it's been through so many twists and turns on what type of mission it's going to support. When it started, it was we're going to the moon, and then it was we're going to moon and ISS, and then it was we're going somewhere, and then it was we're going to an asteroid, and then it was now it's back to the moon. And so it's been a very I would say tortuous path of what Orion as a vehicle was supporting. And a lot of the design, as I mentioned, was potted back in those early 2000 timeframe. And that was when we were doing, the lunar and ISS type missions. But even things were scrubbed off from there to be able to do a station mission was scrubbed off as well.
And so
Sorry, I hope I answered
Well,
your question.
yeah. Also was originally to go on Ares 1.
Yeah, that too.
Right. So I have a couple of questions. One's kind of more of an observation. It seems like there's not an awful lot of redundancy within the systems, the ECLSS system in particular. It seems like maybe you have a backup plan, but not actual redundancy. Was that a weight savings kind of decision?
Yeah, so for the Orion program, the baseline was you have two fault tolerant to catastrophic failures. You don't have two fault tolerant across the vehicle, and so there's a lot of decisions that were made 10, 15 years ago. There was a lot of risk acceptance that was made on the vehicle to say, years ago, people were saying, no, we don't take enough risk at NASA anymore, that we're becoming risk adverse. And so there was that flavor for a period of time. And so from an Orion perspective, it's you have two fault redundancy to catastrophic failures. To critical failures, you only need one fault requirement. And so things like, a perfect example that we're dealing with and have been dealing with within the last year and a half is the toilet. When the toilet was developed, and the architecture for the vehicle was developed back in the early 2000s, and that it was essentially a zero fault tolerant system. You had a primary ventilation vent path overboard for urine, and you had a backup vent path, manual backup vent path. If that primary path failed, it was zero fault tolerant. It's all a single string type system. You had the contingency vent, which is the manual vent as well, but that was the system. Well, nowadays folks want a little more redundancy than that, and so the plan is we're adding some contingency urine bags just in case not only the primary vent fails, the backup vent fails, and now you have some bags that you could probably put some urine into. So that has been also a kind of morphine over the years, depending on how the I want to say that how the flavor of time goes with the needs for it. But there is a baseline of the 2 failures to catastrophic. So things like our swing beds with the CO2 removal system, we have 3 of those. We only need 1 of them to be able to keep the crew alive. But we do have 3 of those. We have 3 of the fans that circulate air through that system. So you only need 1 of those fans to circulate, but we do have 3 of them. So you can have 2 failures and still keep the crew alive. And so it's things like that that we do have that redundancy on those critical systems, but it's not a universal thing of having 2 fault tolerant across the board.
Yeah, the one that really kind of made me think about that redundancy was the single fan for the waste management system.
Yeah.
That would make me feel somewhat uncomfortable, but yeah, okay, we have a backup plan for that. So appreciate that. One of the other questions that I had though was, and it's really just a quick question. You mentioned the flywheel exercise device. Do you happen to know where that was designed?
Yeah, I was actually here at JSC with, probably know KBR,
Yep.
the
Yeah.
contractor. They're the ones that are building it for us. And yeah, health and medical, the HRP program,
Yeah.
human research program, is the ones that actually took the lead on that particular piece of hardware. It was interesting because that one was another one that evolved over time, because originally our first effort at trying to do an exercise device for Orion was going to be a motorized system that would emulate a Rowan device in a compact piece of hardware with capacitors and a motor and be able to give you that resistance and aerobic exercise. It was a really neat system. Is actually being developed out at Glenn Research Center, but budgets again in the mid 2010s got into it, and essentially they had to divert funding to other things, and so we had to go to the backup of the flywheel, which is more of a mechanical system, and for the budget stuff. So that's how some things, pieces of hardware like that, have evolved. But it is created. That one is done here by a human research program at JSC.
Yeah, I was curious about that because before I retired, I worked in the human research program, and we had been approached. I was running the HERA facility, and we had been approached to test some exercise hardware. And the one that we were asked to test originally had come from Glenn Research. So I wondered if they had morphed their original design. It actually, the original design was too heavy and didn't even fit in the HERA. So
That was probably the Rocky, I think, was the one that
yeah.
that was the one from Glenn. It actually was going to be kind of a pretty cool system, but yeah, it just was a little more expensive than what we could afford at the time.
Yeah, expensive in terms of money and probably weight as
Yeah,
well.
it was definitely a little heavier, but they were knocking it down.
Yeah, okay. All right, opening it back up to the floor. Anybody have any questions for Paul before we let him get back to work?
I'm just wondering, Paul, this is Allison McIntyre.
Hey,
I'm just
Allison.
wondering if if there's been any discussion or prep or fear. I know SLS is a little worried about the new administration, but is Orion safe in your mind with the new administration?
That's, am I allowed to say that on a recording?
Define safe.
Yeah, it's been interesting because since I've been in Orion since 2011, it was, I hate to say it, it was constant fear of being canceled. I mean, that was the first 6 years I was working in this program. Every year was a battle to say, how do we stay within a budget and not ask for more money. And that's what the program did to survive. And so I'll be honest, I don't know, Allison, to answer your question. I think we are. I think we've got a good system. Like I said, this is the closest we've ever been to having an actual crew vehicle again to go to the moon in all the time I've been here. And I'm excited for it from that perspective. Is, there's a vehicle that's sitting there at KSC that right now could take crew to the moon, and we just got to finish the testing of it. But it's built, it's getting ready to go. And so to me, that's always been that big thing. Like we always said, is, hey, if you're building stuff and you're launching it, that makes it a lot harder to get canceled. But that I don't know what that future brings right now. I was reading some of the articles myself last night, and so we'll see what happens. But I'm excited from the standpoint of, I think Orion is close, and we're hopefully going to get there within the next year.
Well, at least he is definitely pro-human spaceflight.
Yep, sounds like it.
So that's a positive, I guess.
Yeah.
All right. Well, thank you. Thank you.
Sorry, I was muted. All right, great question. Thank you, Allison. Any other questions? I'm not sure Paul really wants to have to go back to work.
This is fun. And I appreciate you guys letting me come talk to you about it. It's one of those things where it's like, I don't know how much is getting out there about what Orion's doing. It is a little, I'll be honest, from my perspective too, it's a little different the way things operate nowadays with NASA, and being able to share information about what we're doing in that versus what I was used to on shuttle and station. Companies are protecting things a lot more.
All right, perfect timing, I guess.
Never fails.
Yeah. Hey, well, the timing was pretty good at least, and we don't need you to share the screen any longer, so that should help with the bandwidth just a little bit. But
any insight on the heat shield status and what they're going to do with that?
Actually, they just announced that today. We are going with the Artemis 2 heat shield, and we're going to use it as is. They're going to modify the trajectory for entry to bucket that, and so the Administrator Nelson just actually had a press conference today where they just announced that, and so the new launch date right now is April 2026 because of that.
So no skip, just a direct entry.
I believe that's what it is. The period of time.
I think that's what I remember hearing.
Yeah. So they are definitely modifying that to do that.
Okay.
Okay, great. Thank you very much. I'm going to go ahead and wrap it up. Paul, really, really appreciate you agreeing. For those of you who are still online, Paul lives up the street from me, and I twisted his arm one day to be our speaker for this event. So very, very grateful that you could join us. Thank you to everybody who was online. I know we've already lost a few people. We did record today's session, so the video recording should be available on the NAL website in just a couple of days. A couple of other things that I want to mention to you. We will not have a NAL First Thursday in the month of January. So our next First Thursday will actually be on February 6th. And so I'll get all the information out in time for you to join us on February 6th. So in the meantime, again, thanks to everybody for being here. And I want to wish everybody a very Merry Christmas, Happy Holidays, and we'll look forward to seeing everybody in the new year.
Thank you, Lisa. Thanks, everybody.